Hello and welcome to the first video of our flipped classroom. This one's probably going to be pretty boring without all the bells and whistles, mostly because I'm sick, but partly because I'm trying to figure out how to do all this tech-savvy stuff. So today we're going to be beginning our unit on radicals. In the first lesson of this unit, we're going to address the following concepts. We're going to review the idea of squares and what it means to square a number. We're going to introduce square roots, which will mostly be a basic review that we'll build upon later. We're also going to move into identifying and defining rational versus irrational numbers. But first, let's clear some things up. What exactly is a radical? And a radical is basically anything which uses this symbol, which, neatly enough, is called the radical symbol. Anything that's underneath here is called the radicand, R-A-D-I-C-A-N-D, the radicand. And anything that's here in this little crook, not written out in front, but anything that's a small number here is called an index. We're going to be dealing with square roots, so the number here is really a 2. We don't write that because it's implied if it's not there, it's a square root. But this is just some terminology for you to be familiar with. Like I said earlier, in Math 1, we're going to focus on the case of the square root radical. Before we begin talking about square root radicals, we need to refresh our knowledge of a square. What is it? What is a square? What does it mean to square a number? Written out, we can say x squared, which really means that we're taking this x here and we're raising it to an exponent or power of 2. This exponent tells me how many x's I'm going to multiply together. So here x to the second power means I'm going to multiply 2 x's, x times x. In 3 squared, again, it's going to tell me how many times I'm multiplying 3. So here I've got 3 to the second power, so I'm going to multiply 3 times 3. I have 2 3's, which is 9. Do not be confused and think of this as 3 times 2. That's a totally different beast. Remember, the exponent tells how many times the base, or whatever this number is, that you're multiplying together. In this case, since it's 2, I'm going to multiply 2 3's. 3 times 3. Useful information to know are our perfect squares, or numbers that are the result of squaring another number. What does that mean? For example, 4. 4 is a perfect square because we can take 2 and square 2, and we end up with 2. Remember, this tells me how many 2's I'm multiplying together. 2 times 2, and that gives me 4. Because I can square some other number and get 4, 4 is a perfect square. What are our other perfect squares? And we have a lot of them. There's an infinite number of perfect squares. For our class, you have to memorize the first 20 perfect squares. Trust me, you're going to be very glad that you did. You also need to know what their square factor is. Basically, if I gave you 49, you need to know that 49 is a perfect square and its square factor is 7 because 7 times 7 gives me 49. You are going to have a quiz on these, so you just need to memorize all of these numbers. 1 squared is 1, 2 squared is 4, all the way up to 20 squared, which is 400. You should know all the way up to 12 because that's just your basic multiplication tables. So really, all you really have to learn here is 13, 14, 15, 16, 17, 18, 19, and 20. And even if you can't memorize them, you should be able to do your long multiplication and multiply them out, like 15 times 15. This is just a brief introduction to radical equations, so when we have an equals mark and we need to figure out what x equals, we're going to work more with these later, but I did want to go ahead and introduce the topic. So just like we undo an operation with its opposite, like undoing multiplication with division. For example, if I had 3x equals 12. Here, 3 and x are being multiplied, so to undo that, I have to divide both sides by 3. So that goes away. I end up with x is 4. My opposite of squares or square roots is to take the square root or to square both sides. So here, to undo squaring, I would take the square root of both sides. When I take the square root of a number that's squared, basically, those things cancel and I'm left with just what's under the square root, so x. And then the square root of 169, which when you memorize those, it's going to be 13. In this case, we also have to have a negative 13, but we're going to talk more about why that is later. Here, if I start out with a square root, I need to undo it by squaring both sides. So here this gets rid of my radical and my exponent. I'm left with just what's underneath is 14 squared, which is 196. But again, we're going to be doing a lot more with this later. This is just a brief introduction to how to do square root radical equations. So here's a big concept. Rational versus irrational numbers. And rational numbers are those numbers that can be written as a ratio. Notice that rational has the word ratio in it. And what is a ratio? And a ratio is a fraction. Okay, I can write it as a fraction. This includes whole numbers, integers, repeating or terminating decimals. We're going to talk about how to turn these into fractions later. Just your straight up fractions and their opposites, so that means all negatives. So each one of these numbers here falls into one of these categories. We have a whole number. I can write this as a ratio of 1 over 1. Here is our repeating decimal, so it falls into the category of rational. Here, if I was to write this on top of each other, which looks nicer, 15 over 4, here I have negative 2 and 34 over 100, which would simplify. And here I've got 12 over 3, which also is 4 over 1. All of these can be written as ratios, so they are all rational numbers. Irrational numbers are numbers that can't be written as an exact ratio. And this is really where our radicals come into play. Now, some radicals we have are rational. Each one of these radicals are rational numbers. Do you see any patterns? I've got the square root of 4, the square root of 169, the square root of 25, the square root of 81. All of these numbers are rational because when I simplify them, or I can go ahead and say, okay, this is 2, this is 13, this is 5, and this is 9, I end up with a whole number each time that I can write as a ratio by putting it over 1. So all of our perfect square radicals, notice that each one of these numbers in the radicand, remember that's the number under the radical sign, each of our radicands is a perfect square. So anytime I have a perfect square radical, my answer is rational. But what happens when I do not have a perfect square? 2 is not a perfect square. In this case, I have to think, well, what number multiplied by itself will give me 2? And the closest that I can really get here is 7 over 5. What are you talking about here? Well, if I take 7 over 5 and square it, which means I'm going to take 7 over 5 and multiply it by 7 over 5. 7 over 5 times 7 over 5. My rules of fractions tell me I multiply top to top, bottom to bottom, and I end up with 49 over 25. 7 times 7 is 49, 5 times 5 is 25. Notice that this is almost 2. If this was 50, I would get 2. But it's almost 2, but not exactly. This is the closest that I can get. No number multiplied by itself will give me 2. I can't do it. It's impossible. Therefore, the square root of 2 is really as simple as it gets. I can't rename this as anything else. I can't rewrite it. it's just square root of 2. This is an irrational number. I can't express it as a ratio. I can approximate it. This is almost, but it's not exactly the square root of 2. So this number is irrational. This is very key. Radicals that are not perfect squares. So when the radicand, what's underneath the radical, when this is not a perfect square, then it's irrational. So in the case where square root of 4, this is a perfect square, so it's rational. Square root of 16, perfect square, this is rational. Square root of 15, not a perfect square, so it's going to be irrational. You look at the radicand, and it will tell you whether the number is rational, if it's a perfect square, or irrational, it's not a perfect square. Note that just because a number is a decimal does not mean it's not perfect, because what happens when I multiply decimals together? For example, if I have 1.5, 1.5 squared means 1.5 times 1.5. If I did that through long division, I end up with 25. This is 7. Bring my 0. 1 times 5 is 5. 1 times 1 here. Then I have 5, 12, and 2. I have 1 decimal, 2 decimal places. So I end up with 2.25. Because I took 1.5, multiplied it by itself, or squared it, and ended up with 2.25, 2.25 is a perfect square. And because the radicand, what's under here, is a perfect square, this square root of 2.25 is rational. It's actually 1.5. So always double check to make sure the number under your radical sign is not a perfect square before banishing it as irrational. Just because it might not look nice and neat doesn't necessarily mean that it's not rational. You always have to double check and see. So that concludes our lesson for today. Remember to complete your WSQV. So you've watched, you've summarized 2 or 3 sentences with important concepts. Yes, those have to be complete sentences. Come to class with at least 1 question about the material, and have your parents verify by initialing in your planner that you actually did this. Hope you have a great afternoon, and see you later.